Hello, everyone. From our previous lessons, we learned that there are 5 methods for setting tool coordinate systems. In this lesson, we will learn about one of them, the 6-point method. This lesson mainly consists of 2 parts. First, let's learn how to set tool coordinates using the 6-point method. Follow these steps. Press Menu, Setup, Frames to enter the Coordinate System Settings interface. After entering the Coordinate System Settings interface, press F3, Other. Select Tool Frame to enter the Tool Coordinate System Settings interface. Move the cursor to the Tool Coordinate System number to be set and press F2, Detail, to enter the detailed interface. In the detailed interface of the Tool Coordinate System, press F2, Method, move the cursor, select the setting method, 6-point, XY, and press Enter to confirm. In the 6-point method Tool Coordinate System setting interface, we need to teach the robot 6 points. When the approach point is not taught, uninitialized is displayed after each approach point. If the robot has been taught the points, used is displayed. Each approach point has 3 steps. 1. Adjust posture. 2. Point to point. 3. Record. We should note that when recording points in the X and Z directions of the tool coordinate system, we can simplify the operation by aligning the X and Z axis of the tool coordinate system parallel to the world coordinate system axis. The method for recording approach point 1 is 1. Move the cursor to approach point 1. 2. Switch the teaching coordinate to world coordinate, world, and move the robot so that the tool tip touches the reference point. 3. Press Shift plus F5, Record, to record. Recording approach point 2. 1. Move the robot about 50 mm in the plus Z direction of the world coordinate, world. 2. Move the cursor to approach point 2. 3. Switch the teaching coordinate to joint coordinate, joint, rotate the J6 axis, flange face, at least 90 degrees, but not more than 180 degrees. 4. Switch the teaching coordinate to world coordinate, world, and move the robot so that the tool tip touches the reference point. 5. Press Shift plus F5, Record, to record. 6. Move the robot about 50 mm in the plus Z direction of the world coordinate, world. Recording approach point 3. 1. Move the cursor to approach point 3. 2. Switch the teaching coordinate to joint coordinate, joint, rotate the J4 and J5 axes, not more than 90 degrees. 3. Switch the teaching coordinate to world coordinate, world, and move the robot so that the tool tip touches the reference point. 4. Press Shift plus F5, Record, to record. 5. Move the robot about 50 mm in the plus Z direction of the world coordinate, world. Recording orient origin point. 1. Move the cursor to approach point 1. 2. Press Shift plus F4, move 2, to return the robot to approach point 1. 3. Move the cursor to orient origin point. 4. Press Shift plus F5, Record, to record. Defining the plus X direction point. 1. Move the cursor to X direction point. 2. Switch the teaching coordinate to world coordinate, world. 3. Move the robot so that the tool moves at least 250 mm in the required plus X direction. 4. Press Shift plus F5, Record, to record. Defining the plus Y direction point. 1. Move the cursor to orient origin point. 2. Press Shift plus F4, move 2, to return the robot to the orient origin point. 3. Move the cursor to Y direction point. 4. Move the robot so that the tool moves at least 250 millimeters in the required plus Y direction using world coordinate, world, mode. 5. Press, Shift, plus F5, record, to record. When the 6 points are recorded, a new tool coordinate system is automatically calculated. The data in X, Y, Z represent the offset of the currently set TCP point relative to the center of the J6 axis flange. The data in W, P, R represent the rotation amount of the currently set tool coordinate system relative to the default tool coordinate system. After setting the tool coordinate system, can we use the tool coordinate system immediately? How can we know if the tool coordinate system we set meets our needs? This is what we will learn in the second part. First, let's learn how to activate the tool coordinate system. There are two methods. Method 1. After setting the tool coordinates using the 6-point method, directly press PREV to return to the tool coordinate system settings interface. Or return to the tool coordinate system settings interface through menu Setup Frame. Press F5, set in. The screen will display. Enter frame number. Use the numeric keys to enter the tool coordinate system number to be activated and press Enter to confirm. The screen will display the activated tool coordinate system number, i.e., the currently valid tool coordinate system number. You can also press Shift plus QWERTY to display the tool coordinate system number. Method 2. Press Shift plus QWERTY. A yellow dialog box pops up. Move the cursor to the tool line and use the numeric keys to enter the tool coordinate system number to be activated. At this point, the tool coordinate system activation is complete. Next, let's learn how to verify the tool coordinate system. First, verify the X, Y, Z directions. 1. Switch the robot's teaching coordinate system to the tool coordinate system through the QWERTY key. 2. Teach the robot to move along the X, Y, Z directions and check if the direction settings of the tool coordinate system meet the requirements. Then, verify the TCP position. 1. Switch the robot's teaching coordinate system to the world coordinate system through the QWERTY key. 2. Move the robot to align with the reference point and teach the robot to rotate around the X, Y, Z axis, checking if the TCP position meets the requirements. It should be noted that the tool coordinate system should be verified according to the robot's application requirements. If the verification deviation does not meet the requirements based on the robot's application, repeat the setting steps. Everyone, through today's mini lecture, we have not only mastered the essence of setting tool coordinate systems with the 6-point method but also deeply appreciated the importance of precision and rigor in industrial production. I hope you can integrate this spirit of craftsmanship into your daily life and contribute to achieving the dream of becoming a manufacturing powerhouse. See you in the next lesson.